Alright, so the problem X is for how far the car has traveled. We use the average velocity equals displacement over time formula, solving for the displacement. There's three different situations that we would use. First being the time interval from 0 to 4 seconds, find the constant velocity. The second being the time interval from 4 seconds to 12 seconds, find the constant acceleration when the car slows down. And then the third part would be the time interval from 12 seconds to 16 seconds when the car is stopped and there would be no movement. So for the first constant velocity, we'd use the velocity average equals delta r over delta t, solving for the displacement. We'd use 20 meters per second times 4 seconds, which gives us 80 meters. For the second part, we use the velocity average equals velocity final minus velocity initial divided by 2, using the absolute value of the velocity final minus the velocity initial because we're solving for magnitude. So it'd be 20 divided by 2, which equals 10 meters per second. We'd plug the 10 meters per second into the same formula we used for all three of them and multiply it by 8 to give us 80 meters. For the third part, the car is at a stop, so there's no movement, so the displacement is 0. To find the total distance traveled, we'd add all three of them together. R1 plus R2 plus R3. R1 being 80, R2 being 80 as well, and R3 being 0, which equals 160. Here is a position of the car over time graph in 2-second intervals. At 2 seconds, the car moves 40 meters. At 4 seconds, the car moves 80 meters. At 6 seconds, the car moves 115 meters. At 8 seconds, the car moves 140 meters. At 10 seconds, the car moves 155 meters. And at 12 seconds, the car moves 160 meters and stays that way for the remaining 4 seconds until it gets to 16 seconds.